Hello, Dora. Can you hear me?
Yes, I can.
I can't hear you.
You can't?
It could be me though. Let me see. Apple sound. Oh, it's me maybe. Can you hear me now?
How about you?
You're a little bit low. Oh, here you go. Try one more time.
Okay, can you hear me now?
I can hear you. Yeah.
Okay.
So I have some of my 7th graders. You want to say hi to Dora from Imagi?
Hi. Hi, everyone.
So are you going to share for us?
Yes, I was going to ask you, should I, or like, I guess we split up the slides, so I would go through in the beginning.
Yeah.
Or should I be sharing the whole time, or we can switch?
I might, let's see. Let's see how easy it is. Should I try real quick? Share screen. Okay, I think I can do it. If there's a problem, then you can just jump over. So I need to stop sharing. Okay, perfect. You good?
Yeah.
All right. Yeah, so you're going to start off sharing. And then what slide do you want me to pick up on?
Let me see. It was when we'll get into the debugging buddy, I think.
Okay.
Or
you know what we should do? I tried to test it. The sound. Was it at the video? Yeah. I was one. Yeah, I don't see you anymore. Let me go jump back. Okay, let me check that slide number.
14.
14. Because I just wanted to see if you could. If I play it, do you hear the audio?
On the project. Yeah. Type in eye color. Okay.
Are you hearing the audio from the video?
What? Eye color, not to.
I am. You not?
Yeah. Okay. It says, I see you have an error in your code. Do you want to use a tip token to understand this error? Yeah, we need help.
Oh, I just closed it. My bad. All right. Got it. So I'm just going to queue up after that slide. So I'll be ready to jump in.
Awesome.
Okay. So, but then are you going to talk about the states, 35 states? And
oh, that's true. It's me after that as well. And then you will take over, I think, when we are. So I'll do this one. And then you take from here.
Okay. So 13.
So you can start sharing from here. 17.
Okay. So slide 13. Okay. Perfect.
17,
perfect. All right.
Okay. Well, hi, everyone. Yeah, sorry, we're still just doing the logistics, and some people are already here watching. I'll jump back to the beginning.
Awesome. Morning, Tom. Good morning, Mike. And everyone else.
Good question. So, to the privacy point and question, we don't collect any student privacy data, like student data. So there is no student email or student, like no student information. So that's why imagi usually like qualifies for most privacy requirements. We are also on the like BOSI's consortium contract, which involved like a pretty thorough privacy review. But I can share the privacy policy. And then, yeah, regarding district questions. So we are part of the New York State wide BOSI's consortium contract, which means that we already signed a specific privacy agreement. So I believe that should apply to all New York State districts. I'm not sure if some of you are not from New York State, then yes, in certain cases we need to sign separate agreements. Okay. should we dive into it, or yes, we're at time now. Awesome. Great. So as you're entering the session, we have this slide up here. You have the opportunity today to actually follow along, like coding. And so if you wanted to use imagi, you can sign up for a free account as an educator, and you can test it. So I'm just going to copy and paste the link also here in the chat so you can access it. And I will come back to this when Kelly takes over for the actual coding part. Awesome. So yeah, welcome everyone. You also have the opportunity to follow along today. Whoopsie. The slides. So if you wanted to actually like have the slides up, then you can also do that. I'm sorry, I'm going to have to just try to copy. Let's see the link here for you to be able to follow along as well. But yeah, while I'm doing that, I thought we can just start with some quick introductions. So my name is Dora, and I'm the co-founder and CEO of Imagi, and really passionate about computer science education, but also about inclusion and diversity. And so a really big mission has been to make coding fun and accessible for everyone. And then Kelly, you can take over.
Hi, everybody. I'm Kelly Powers. I work at the Hackley School in Tarrytown, New York, and I've been part of the computer science education community since 2005, and fortunately met Dora, and I've been using Imagi for 2 years now in my 7th grade classroom.
Yes, with some incredible students that I've had the chance to visit in person as well. So when it comes to today's agenda, we wanted to start with just a quick introductions. And we did want to touch upon this topic that we believe is really important to address around coding in the age of AI and why it's still important, and also how AI can strengthen computer science education. And then Kelly will take over with a more interactive part and actually doing some hands-on coding. And then you will also have the opportunity to do that. And I will wrap up and share some resources. So that's the plan for today. Okay, so just for a little bit of introduction, some of you might be familiar with the 4 Ps of creative learning, which is also the underlying foundation of Scratch. And it's been popularized by the lifelong kindergarten concept and Mitch Resnick at MIT Media Lab. And so at Imagi, we believe that we are not just incorporating these 4 Ps, but we're adding the 5th P, which is Python, to make it a whole picture. But essentially, our entire paradigm is around creating art and animation with code. And so it is very much a project-based and project-driven learning opportunity, because our students always end up with some kind of like final visual outcome. Some of the things that you see here, actually, some of these were created by Kelly's students, represent passion. So for example, this art piece here, it's made up of 18 of our 8x8 matrices. And I don't know if someone can tell. Actually, I showed this example in a school yesterday, and the students could tell that this is from the Pirates of Caribbean, as well as Jack Sparrow. So it's a lot of like passion that really drives students to spend even their weekends or extra hours coding with Imagi. Then there is a big part of peers. So a lot of these projects end up being collaborative. So I believe this basketball player was a collaborative project between multiple students, right? Yes. Yeah, so essentially just to exemplify how the 4 Ps are incorporated in Imagi. So as I alluded to it already, we teach Python coding through creating pixel art. We believe that Imagi is a really good first step into script-based coding. So if your students are already familiar with Scratch or other block-based coding, and they have the ability to type, that would be kind of the limiting factor to be able to type. Then it is a perfect first step into the world of script-based coding in a way that's creative, social, and a good established project-based. And so the platform that we shared here now, imagiCharm, is our school platform. And that works either on Chromebooks or any other computer, so it can be web-based. But if you do have tablet devices, you can download it as an app for your students. And that has the platform where you can actually code create your classroom, see your students' projects, and also see our lesson materials. And then the Imagi EG platform, or our software solution, and the art that kids create can actually be paired with the imagiCharm. So the imagiCharm is a small gadget that, oops, I have a blurred background, so it turns on and it brings code to life. So whatever the kids code, they can connect via Bluetooth. So for example, this is an example of an Among Us character, which was very popular during COVID. And then I think the next one is, yeah, like a melting ice cream. So yes, so many questions already. So typically 10 of them would be around $790. And that would be like a class kit, or, well, technically, I guess you could use it for a school. So that would be usually the use case that students would be sharing the imagiCharms. And then we have the Imagi mobile game, which I just wanted to mention, because if students want to also continue coding at home, there is this free app that has a global community, so that requires parental consent, so they can continue coding that way. Okay, so that was a bit around the introductions. And so I'll jump into our second topic, why we believe that learning to code still matters in the age of AI. And so there is this interesting concept that Kelly shared with me from Jane Wright at the Raspberry Pi Foundation, but actually it's also a topic that came up. If some of you were at the CSTA conference this summer in Las Vegas, there was another session there where we addressed the same concept of computational thinking 2.0. And so computational thinking is going to remain incredibly important, but AI is essentially just transforming what part of it might be more relevant. So, and that's kind of like true how like calculators have transformed mathematics, or access to Google has transformed knowledge, that oftentimes it's not necessarily about like knowing things, factual things, memorizing, but it's a lot more about understanding concepts. And then the way how AI can supercharge the skills is by kids knowing the basics, then they can use tools. So if the math analogy would be like, if you don't know how to do basic mathematics, you can't use calculators to do those computations. And so for us, it's been really important that when we teach coding and computer science, especially in a middle school context, it's really not about securing a job in tech. It's about a lot more than that. And so building equity also in tech starts with accessibility at an earlier age. And so having those fundamental computational thinking skills, but also having the confidence that students can create with tech is a really important baseline, so that we can build on top of that, and they can then go on to learning technical skills in university. And probably today we can't predict what today's middle schoolers will be learning in computer science in university, but the point is to just make sure that they have the fundamental understanding, and also to my in my personal mission, the confidence really that they belong to this space. And so we think that using coding and using AI to supercharge coding skills can be a very powerful path also for students to just strengthen their computational thinking skills. But of course, this is something that's constantly evolving, so there's a lot to be seen over the next years. And so we at Imagi have like a new feature now that I'm going to show in a second. But again, our understanding and kind of theory is that we can teach the basics, the computational thinking, and also really make students understand the basic syntax when it comes to Python, how to start coding, but then they can use AI alongside to strengthen these skills. And then we think that the actual skill set of working with AI on problems is also going to be very important for the future. So some things that AI is really good at, right, is breaking problems down into smaller pieces, making abstract concepts more approachable. Then again, essentially, we have educators who are maybe really experienced at computer science already, but then there's also a lot of computer science teachers out there now who haven't had a whole lot of coding background, and that's where AI can become a very cool companion for them, so that it can, give more personalization, more explanation, and really just, be their co-teacher, just the same way as it is a co-pilot for software engineers. And so I'm going to get into this in a slide a bit about the teacher statistics, but that's a really big part of it for us. So essentially allowing teachers who might not have done computer science so much in the past to become confident and proficient. And so the feature I mentioned, it's called our AI-powered debugging buddy. And essentially what this does is it explains the error messages and answers coding questions. And especially if you've done coding before, you probably know that error messages are, a very normal part of writing code. It's very rare that someone gets everything right at the first time. So actually error messages are part of the process of debugging and finding where we might have made mistakes, where we might have given an unclear instruction to the computer. And so a really big part of what we're trying to also convey to students is that error messages are their friends, but they can be a bit complicated if you're not so familiar with them. So then we have this additional layer of an AI explaining what an error message really means. And so what this can mean in practice, maybe it says the error message could be unexpected character in line 34, but it doesn't explain what is the unexpected character and why that character, let's say, should be a colon instead of a semicolon. And so then this AI debugger buddy takes that to the next level. So it does give very specific feedback to the actual problem that the student might be facing. And just on a final note here, because recently I've been going into a lot of classrooms and observing both students and teachers. And of course, when you have a limited time to do coding projects, it can be very frustrating if students get stuck on small errors. And so we're trying to just maybe accelerate or make that process a bit smoother, so more of the learning can happen. Okay, so I'm going to play this video quickly that actually Kelly recorded with her students. Hopefully you can hear the audio.
Oh, let's work on the project. Yeah. Type in eye color. Okay. Let's try it. What? Eye color not defined. Let's ask the debugging buddy. Yeah. Okay, it says, I see you have an error in your code. Do you want to use a tip token to understand this error? Yeah, we need help. Okay. The error message you are seeing is due to your typo in code. You have to find the variable eye_color, but when trying to use it, you wrote eye color without the underscore. This causes name error because Python cannot find a variable named eye_color. To fix this error, you should use the correct variable name eye_color in your code. Oh, we forgot the underscore. This was definitely helpful. Okay. Underscore. Okay, let's try it out. Yay!
Did it work?
Yeah.
So what do you think about the debugging buddy? Is it helpful?
It's cool. Yeah, I like it. It just helps when you're making an error in your code and you don't realize it. Instead of asking for help, you can go on the computer on the website and look it up. Yeah, without it, I probably wouldn't have been able to see the error because it's so small that I wouldn't have realized it.
All right, nice job, ladies.
Thank you.
Yeah.
Oh,
sorry. So we're gonna get into coding in a second, but yeah, so this was Kelly's students actually using a debugging buddy in action. And so I alluded to the fact that why we think this can be so helpful is because, again, teachers have to work with a lot of students, but on top of that, the numbers I'm showing here is the recent growth in expectation for computer science education. So there's about 35 states in the US right now that already require teaching computer science. But then recent studies have shown that about 60% of teachers who have been asked now to teach computer science to comply with these requirements feel unequipped to do so. And also 58% of superintendents believe that their teachers would need additional training to be able to, again, comply with these requirements. And so that's where with Imagi, this has been a really big question for us. How do we make sure that every teacher can deliver successful and engaging computer science lessons, because this is a really big part of the equity question in computer science. And so what we're doing at Imagi, so one part of it is that what I introduced in the beginning, we create art with code. This leads to a lot of student choice. This leads to a lot of intrinsic motivation and personalized experience. So this has been the part of our development where how do we make sure that coding is appealing to every child? But then the second part of it, how do we make sure that every child can get that engaging and quality computer science lesson delivered to them? And so that's where we focus a lot on that, how to empower teachers who maybe come from, business or art or social studies or really any other background. We have even former English teachers who are teaching coding with Imagi. And so that's where our very detailed lessons plans and slides are very useful. But then to the actual coding process and eliminating bugs, this is where we see that AI can be a tremendous help for our teachers, so that their students can get that specific feedback and help whenever they need it, and then hopefully not get so frustrated with coding and enjoy it. So that was all on the introductory side. Sorry, I spoke a bit long, but now we'll get into the fun part, the coding part. So I'll let Kelly share the slide.
Okay. Share screen, and we'll jump in here. All right, can you all see my screen? Yep. Okay. So what I want to just emphasize is what Dora has said, is that the materials are so rich, and I'm very critical of curriculum that I choose to bring to my school and my students. They've designed this incredible product that is really helpful, engaging all students. And I'll say that again, like every single one of my students is super engaged in their work, and it's because it allows them to express their own art through code. So they will invest the time in coding to be sure that they can show their art and their creativity in their project work. So today, what we're going to do is we're going to try to dig into a little bit what this interface looks like. So right now you're seeing what we call the matrix, right? So students are exposed to a grid of pixels, and the goal is to make pixel art. So they're very constrained, which is good and bad. If you ask them, they want more pixels to work with. But basically, we teach them how to navigate this matrix, and we talk about rows, and we talk about columns. So if we were to look at this matrix that we're going to be coding to pixel art, there are 8 rows, and there are 8 columns. And the biggest hurdle initially is having students understand that rows go across and columns go vertically, go down. So when we reference a location on our matrix, it's called a pixel, and each one of these pixels in the 8x8 matrix has a location. So right now, I am looking at location by row and column. So we would refer to this as matrix spot 2, 3, or row 2, column 3. So each pixel in this view that you're looking at has a specific location on the matrix. We make the analogy to a chessboard. So some students in class do play chess, but they usually refer to a location on a chessboard by the column, by the letter D, and then the row. So they would refer to this spot on a chessboard as D6. So we just have to retrain their brain to reference pixels by the row number and then the column number. So for example, to turn a pixel on in Imagi, your first line of code might look something like M is for the matrix. It's a special variable, and it references the matrix and what position or what spot do we want to turn on. So we're turning on row 2, column 3. So the second hurdle besides rows and columns is finding the braces on the keyboard. So it's very important that kids learn the syntax of Imagi. So again, we're referring to this spot as spot 2, 3, and we're turning it on. So very simply, the kids can now develop a simple algorithm, a sequence of instructions to create an image. And one of the first images we work on is creating a smiley face. So again, given this one instruction, teaching the kids how to turn a pixel on, we can then ask them to go ahead and with that knowledge, can they write a sequence of instructions or an algorithm to create this smiley face? So if we had an interaction with you, we would say, well, what location is this pixel in that I'm pointing to? And hopefully somebody from the audience would say row 2, column 5, and then we can go ahead and code that particular instruction in our project. So you can code along with me now, or I can just keep going. Just communicate through the chat, and Dora will interrupt me if needed. So if we were to proceed creating this particular pixel art, you would go into the interface, which is the edu.imagilabs.com or .org, I forget, I'm sorry, Dora. And in the blue toolbar here, you click on projects, and then you would click new to create a new project. And again, if you're logging into the site, you want to get an educator account, you would go to projects, new project. And we're interacting with the matrix with the instructions of that looks similar to this. M stands for the matrix. It's a special variable. And this is the location row 2, column 2. I'm turning it on. So this sequence would create this project in imagi. And one of the computational thinking skills that we're having students use and practice for this exercise is decomposing this shape into a sequence of instructions to turn pixels on and turn pixels off. And I'll just pause for a moment just to see if there's anything going on in the chat. So we do have a question about how long the curriculum takes. Is it a few weeks, a half year? I don't know if Dora, you want to take that. It depends, I guess, is always a great answer.
Yeah, so what I wrote in response now is that we are launching our new extended curriculum in January, and that's going to have about like 50 hours of instruction time, which is a lot, I think, that for computer science, plus a lot of additional time for like free activities. So I think I was curious, what do you think, Kelly? Because I think your students have taken a lot of time to just like do free coding as well, and not just the strict curriculum. But yeah.
So what I like to do is we build skills. So this is just building sequences. That's just one concept in computer science. And then there are a set of lessons that talk about loop structures, so control structures in computer science. And Imagi gives us a lot of great challenge and projects to create all sorts of flags from all different countries. The kids absolutely love it. And then we move on to conditional statements with if else, elif statements. So in the middle, before we switch in the concept development, we have like a mini project. So we might have a project just using a sequence of instructions that kids will work on that they're passionate about. So there's not a definitive answer. It depends how much project time that you bring into your curriculum. I see my kids just say 10 weeks, 2 times a week. So within 20 weeks, we are able to cover things like sequence and for loops and functions. So we're able to develop skills, conceptual understanding of those 3 big concepts in computer science. But I am thrilled to hear from the Imagi team that they've come out with course 2. So I can expand my student experience beyond 1 term, seeing them about twice a week. So to get the brackets in our code, on my keyboard is the Shift key, and then it's next to the letter P, and then it is a parenthesis, like not a parenthesis, but a squirrely bracket, but a square bracket is the Shift on that next to the P key on my keyboard. I'm not sure if that's for everybody. All right. So
okay, thank you for answering that, because I have a Swedish keyboard, so I was like, oh no, I cannot answer this question.
So the first lesson is really straightforward. The kids get there easily. They can build a sequence, turn pixels on, pixels off. But now let's add some color to our designs. So Imagi gives us, or Python gives us, some system variables. They represent specific colors. Here you see a slide. R is the variable red, and case does matter. So red, blue, purple. So these are amazing colors that kids can now start to bring into their design. Usually by the end of the first lesson or the beginning of the second lesson, we are now able to assign color to our artwork. And this is really exciting for our students, is that they're able to use the system variables to assign color to their pixel art. And this is a pretty straightforward exercise for the kids. But then we start to move into mixing of colors called RGB colors. So can students create their own colors and update their artwork through code? So what's really beautiful is Imagi gives us a design tab. So if you're working in Imagi now, there's a coding tab and then a design tab. And it's really user-friendly. Kids can mix colors. And not only can we mix colors to create our own colors, Imagi gives us the RGB code to add to our assignment statement for the pixel. So for example, in this pixel of a dog, it has a fur color of a lot of red, a little bit of green, and very little blue. So we've mixed this color and we want to assign it to location 2.2 in our artwork, location 2.3 and location 2.4. So again, what's really beautiful is we can just copy the RGB that we just mixed and bring it into our code. Kids can spend 2 class periods designing their own colors for their artwork, and they really enjoy that freedom to make it their own. And I can't say enough about this feature of Imagi, the design window. So their first introduction to variables comes with the system variables, which are the color variables. And then we start to move into teaching kids how to create their own variables. In the debugging video you saw, we had a variable called iColor. So students learn to understand the value of a variable in your code and just changing a value in one spot in your code and how that could benefit you. So in this example that you see before you, we're trying to teach kids to, instead of assigning a specific color to the eye using the system variables or RGB colors, you can now create your own variable. So in this example, students are introduced to perhaps creating a variable called eye, make sure that it makes sense, and it's being assigned an RGB color. And we're also creating a variable for the mouth. And we can use these variables in our assignment statements to now update our pixel art with these specific colors. And we can talk about why, well, tomorrow, if we didn't want this color anymore, we can just change one line of code for the eye or one line of code for the mouth, and then our artwork will be updated. So they start to see the benefit of using variables in their code. At the end of the first lesson, Imagi introduces us to something called blink rate. Blink rate is given to us by Imagi, and basically it will take your artwork and it will make your artwork blink a certain amount of times, 2 times per second, up to 3 times per second. It can also be assigned a value of a decimal. So this is kind of interesting for some students to actually see their artwork blink. And again, these are just basic skills that we're introducing in the first lesson, and kids are able to process them and apply these skills quite quickly. So that's another thing I love about the curriculum. They've built sequence, they've been exposed to variables, and now they've been exposed to how might I animate my art a little bit by using this feature called the blink rate. This year, I was introduced to this add-on that was recently added to the Imagi tool, being able to ask questions from the debugging buddy. And one of the great things about using the debugging buddy is most errors in Python, they're short and they're brief. We're building the students' capacity to read. And that may sound funny, but they don't like to read. They want the answers right away. So you can build their perseverance and persistence to solve problems by taking time to read what the debugging buddy has to offer them before you even go over and help them. And as an educator, many of you might already use the asked 3 before me, but it also helps to have the debugging buddy because it's tailored to this environment, and the debugging buddy is giving students advice based on what they're doing in Imagi, which is super helpful. Dora hit on this already, but I can't say enough about how we can use the debugging buddy to really develop students' logical thinking skills, evaluation skills, debugging skills, the ability to persevere with a tool, not only with the tool, but with their peers as well, as you saw Delilah and Daisy working together to really try to understand what the debugging buddy was suggesting to them. And it's just another aid for the teacher and for the students when you're not available to them. So we've built some basic skills with you all. You know how to build a sequence. You know how to reference a location on the matrix. You know how to assign a location, a particular system variable. And by now you might remember the command to make your artwork blink. So we want to pause for a few minutes and see if you'd like to go ahead and create your first design using Imagi. And we're here to assist you if you need some help. So go ahead and create a new project. You can start to sketch it in the design view if you'd like, or you can start coding it in the code view of Imagi. And let's go ahead and type some code and evaluate it and make some revisions. If you get an error, let's ask the debugging buddy, but you also have Dora and I here to help you. So go ahead and get started, and I'll stop talking, and I'll pay attention to the Q&A for a couple of minutes and see if you guys have any questions.
I see a question about the ClassKit and the imagi Pro. I'm just going to type out the answer, but then I can also explain. But essentially, they are almost like two separate. Well, they both can come individually, and they're both optional. So if you're just looking to use Imagi as kind of like an enrichment program or like makerspace or after school, then you could just get the imagiCharm and just use the free version of the software and like the free resources, and that would be enough. That's one part you can do. And then if you want to use it like Kelly does in like the in-class setting, then it's probably the imagi Pro that's more important, and then the imagiCharm is optional. And I think we posted the pricing for the kit, which would be $790 per kit. And then the student license, it depends a bit on how many students you have, but it could be something around like $10-ish, depending on the number of students per year per student.
And just to add on to what Dora said, I the first year I did not use any charms with the program initially. And then when we did have the charm, the students were wowed by it. And so I don't bring out the charms at all. I have a handful of charms, but we're getting more. But I really like them to focus on like the experience of developing their thinking skills through Imagi before they get the charm. And then when they get the charm, it's a real like, wow, this is pretty awesome that they can see their work on the charm. So Amber's talking about the difference between the pro and free version. Imagi, do you want to answer that, Dora?
Yes. So on the free version, you can have up to 50 students in your classroom. And so, of course, well, it depends on how your school works, but you can have up to 50 like student accounts. And then also you get access. So if you signed up now on imagi Pro, you probably you go to the teaching content. You can see that there is like unlocked lessons. And then there is some that are locked. So that's a big difference. And then the debugging buddy, it's also, part of the pro version. So it's up to 50 students accounts, and you can have one classroom. They can be like non-specific accounts because like we said, we don't collect any student data. So you could say student 1, student 2, student 3, and then reuse it. But like at the same time, you could only have 50 students. So I guess like the pro version makes sense if you also need to sort of track your students' work. I don't know how much you do that, Kelly. Like, do you look at students' draft work? So then, of course, I think they can't be shared accounts between multiple students.
Yeah, I'm always looking at their work because I want to see what they complete in class for sure. I'm really, it's really important to me what they're able to complete in class or where they're getting confused. So I do look at all of their work, even their draft work.
Mm-hmm. Yes. But Amber, I try to highlight, I'm not sure if this feature worked, but yeah, you can go ahead and sign up for free and then see if, just try the free version. Yeah.
Yeah, I'd encourage everybody, if you definitely try the free version, and then you'll start to see if you've taught computer science as long as I have, how it's accessible to every student in my class. But even more important than that, we think about what are the key concepts that we want, what are the standards we're trying to teach, what are the key concepts in computer science. And again, that's why I love this tool so much, is that we are hitting on really powerful computer science concepts. And like no other tool that I've used before is able to get kids to really deeply understand these concepts. And it's really through their thoughtful scaffolding of the lessons and the thoughtful activities that these kids do. So I'm very excited that they have a course 2, because even after course 1, I moved my kids into a pure text-based environment. And the activities that I use from this other curriculum, they're not targeted to this audience as much as Imagi has put the thought in. So I really love their activities for these kids. The kids were wishing that they can go back to Imagi last year with my 7th graders last year, because it was just so much more engaging for them. And it was very challenging, but super engaging. So again, I'm not trying to sell Imagi. I believe in, I only promote what I believe in. So I can't say enough about it. It's amazing. Any questions? I'm hoping you guys are tinkering in Imagi. You've got some basic skills you can tinker with. Oh, so for what ages? Yeah.
So we see the most like usage would be like grade 6, 7, but we have anywhere from 3rd through 8th, I would say. The limiting factor for the young ones, again, is the typing. But as soon as they can type, they can probably get started with it. But yeah, I think most success is usually that middle school, like, or maybe like upper, like 5 through 7, I would say. That's the most typical. So for the app question, I'm wondering what device you're thinking, but essentially imagiEdu. So it's we developed it in a cross-platform way, so you can use the website version if you have Chromebooks, or you can download the imagiEdu app on an iPad or tablet. It's important that there is a mobile game, but that's not the one that's meant for schools. So, and if you're on an iPad, just make sure if you're in a school setting to look for imagiEdu. That's the school one.
Okay. We might be coming up on time.
Yes.
So should I stop sharing, Dora, and you take over?
We can do that. Yeah, sure. I was just thinking, yeah, because we're so short on time, I think we wanted to, yeah, maybe, okay, I'm gonna share. Oh, Kelly just jumped off. So I'm going to share my screen now. Let's see, here we are. So with the basics that Kelly showed today, you can already create a lot of the projects that you see here. We didn't talk about animations, so you can do all the static ones, and then a later step is doing the animations as well. Just because we spoke about it today, I already shared this one. This is our standards line kind of like mapping of the lessons. And so the spreadsheet I sent here in the chat shows the course 1 and course 2 that's coming out, and the alignment. We do have New York State specific, but also CST, AST, etc. So that can be interesting. And then we already touched upon the teaching slides a question. And so we provide these as Google Slide templates, so educators can make like a copy, so you can modify it. And I don't know, Kelly, if you do that, do you modify the lessons to your?
Not really modify. I might add the CT concept in the beginning of the lesson that I want the kids to focus on, whether it's decomposition or evaluation. They're going to use all their CT skills, but I might add that. But pretty much they're really awesome.
Mm-hmm. And I think that was based on Kelly's feedback. In the new curriculum that's coming out, there's going to be a lot more reflection on the CT concepts right in the slides as well. Awesome. So we have like 5 minutes. I think what I wanted to show, because I think it's exciting, is just like some really quick examples of integration across the curriculum. And so I shared the slide link also here in the chat. It's supposed to be highlighted, but yeah, maybe Kelly is gonna send it. Yeah, so just like some examples, like Kelly already mentioned, like we have a whole unit where you're coding flags. That's really good for like social studies. This activity where kids like measure their heart rate, and I did it at a school yesterday. The gym teachers were also there, and they made the kids do jumping jacks and then measure their heart rates. And then we were coding, resting heart rate versus after jumping jacks, and just like seeing how fast each one of them is. This is an example from a teacher in Virginia. They were learning about the lunar phases in science class, and they brought in the charm to integrate into science, and actually coded the phases. This is from a teacher in Sweden. They were learning about the periodic table and the elements, and coded the representations of the elements, and talking about that. So there's a lot of fun examples of how to integrate. Or this one from like biology, environmental science, so coding the seasons on the tree. You can even create a dictionary when you get to that point, or your own calculator. And then there's some more advanced lessons where we get into things like cybersecurity and creating a password checker, or even things around like neuroscience or like encryption. So we have the Caesar cipher. So yeah, there's a lot of fun integration ideas. And of course, we always have awesome teachers just coming up with more and more of them. So we collect those. Yes, and so as a final note here, so I'm going to share these slides as well that we're presenting today. And from these slides, you can also access a lot of the other resources. So we do have Educator Handbook. We do have a Facebook community where teachers ask questions and share resources with each other, and just get answers. So I think that's going to be it on our end. Yeah, we have this wonderful project that, again, I think was created by one of Kelly's students for our Q&A side. So if you have any additional questions, do let us know. Okay, thank you, Kelly, for sharing that. Yeah. So from these slides, you get linked to all the different slides. And then I think, again, just conscious of time, but if you do have a moment, we always really appreciate feedback and take feedback really seriously. So while we have the last minute or two, you can scan this QR code with your phone. It's a very short feedback survey. And of course, yeah, feel free to drop additional questions you might have.
And a lot of you are part of Computer Science Teachers Association chapters. You can reach out to me. I'm in New York, so if you needed me to go to a local chapter meeting, I'm in Westchester County. I can go to New York City. So just reach out, because I'm local. But I know Dora's team travels too. So feel free to reach out to her and see what she can do for you guys.
Yeah, I happen to be in New York City right now, but only for like 2 more hours. So yeah. But I hope to connect, and feel free to reach out, and I'll just drop my email as well. It's dora@imagilabs.com. And feel free to to ask any questions. Awesome. Right. Well, thank you, everyone.
Happy Friday.
Happy Friday. Bye.
Thank you, Dora. I didn't realize you were in New York.
Yeah, it was a very short stay actually, but yeah, just now.
Okay.
Yeah, but good to see you, and yeah, hopefully you can see Beatrice. I was actually at an event in Long Island on Wednesday,
Nice.
and then yesterday I was in New Jersey. I was at Spotswood. I don't know if you know Paige. She works at CSE in New Jersey. So,
Not sure.
but I was in their assembly for 4th and 5th graders. So 160 of them were coding at the same time.
That's terrific.
Wonderful.
So much fun. So much
Yes.
All right. Well, I'll keep it. I'll be talking to Bea. I emailed Bea just to see what her availability is, what makes sense. But hopefully we can connect.
Sounds good.
Thank you. Have a safe trip home. I'll see you soon.
Bye.
Bye-bye.